Okay, today we're looking at section 4.2, which is patterns and linear relationships. So hopefully at the end of the video you can say I can identify and represent patterns that describe linear relationships. So a few examples here. First type of thing you might see, might ask you to make a table to show the relationship between figures. So for instance, in this case, trapezoids in the perimeter. So if we looked at the number of trapezoids and compared that to the perimeter, first of all, we got 1, 2, and 3 trapezoids. If you look at the perimeter of the first one, is 15. If you took a look at the second one, all we're really doing is adding these two pieces on, sliding this piece out to count that over there, and that would give us a perimeter of 24. And then the same sort of thing, we're adding these two pieces to count for the perimeter. So we're just adding another 9, so that would be 33. Okay, so write the ordered pairs for the relationship. Well, ordered pairs would be like this: 115, 224, and 333. Okay, next thing it asks is to make a graph of it. So as I've said before, any good graph should have some labels on it. So here I would have trapezoids down here. Excuse the writing. Trapezoids. And over here I'd have perimeter. And we'd have 1, 2, 3 trapezoids. If you haven't seen this little signal, it means that there's a break in your graph, and I'm going to start at 14, and I'm going to go up by 2's. Okay, so the first one is at 15, second one's at 24, third one is at 33. So your graph would look like that. Okay. Second type of thing you might see is this, very similar, except this time it says for the diagram below, find the relationship between the number of shapes and the perimeter of the figure they form. Represented as in a table, in words, in an equation, and a graph. So first of all, a table. So this time I'd have rectangles, and I'd have perimeter. Okay, so we got 1, 2, 3. So for one rectangle, the perimeter would be 6. Next, we slide in these two pieces, and so our perimeter would be 8. Next one, we slide in these two pieces and shift it up, and we'd have a perimeter of 10. Okay, so there would be as a table. If I said in words, what's the relationship here? It should say something like this. When there is, I messed up there. When there is one rectangle, the perimeter is 6. As the number of rectangles increase by 1, the perimeter increases by 2. Okay, so that would be in words. An equation, something we haven't seen yet. Now an equation, when I think of equations, I think of, okay, I think of a start with number, and that is when it's set 0, and then I have an increase by, or decrease by. In this case, we're increasing. So if I have to think of the increase by, we can see from our table that it's increasing by 2 each time. The start with at 0, it can be a little confusing, but we have to think back to if there was 0 rectangles, what would I have? If I went back to 0 rectangles, I'd still have 2 little pieces sitting there. So our start with is, excuse me, I'd have 4 there. Let me erase that a little bit better. So at 0, if I went backwards, I'd be at 4. So my equation would be perimeter is equal to 4 plus the 2 times the number of rectangles. So 2 times the number of rectangles plus 4. So if I had to look at a graph of this now, I'd have 1, 2, 3 rectangles. And over here I got perimeter. So for one rectangle, we had a perimeter of 6. So 1, I had 6. For 2, I had 8. And for 3, I had 10. So that would be a quick graph of my information there. Okay, on my next one. Okay, next one we got to talk about functions a little bit. So a function is a relationship where every input has exactly one output. So what we're going to need to do here is to decide if these tables are representing functions. So the big idea here is a function. So in the first one, we have an input of 2, 4, 7, and 9, and outputs of 3, or 8, 3, 9, and 12. So we have to ask ourselves, for every input, so every one of these 2's, does it have exactly one output? No more than one. So if I look at the 2, there's no other 2. All it has is an output of 8. The 4, all it has is an output of 3. The 7, all it has is an output of 9. The 9, all it has is an output of 12. So this is a function. Okay, if we look at the second one, the 2 has an output of an 8. The negative 4 has an output of a 3. The 6, though, has an output of a 9, and then down here, it has an output of a 12 again. So these two, right here, are breaking our rule, so we'd have to say this is not a function. And I'm going to go back and re-explain this in one other way in just a second. So if we look at the next one, we get an input of a negative 2. It's paired with a 3. We got an input of a 4. It's paired with a 3. Input of a negative 6. It's paired with a 9. A 9 is paired with 12. There is nothing here that breaks our rule of every input has exactly one output. So we would consider this to be a function. On the next one, the input of a negative 2 goes with 8. Negative 4 goes with 3. 6 goes with 9. 10 goes with 12. So again, this one is a function. The way that I like to describe this sometimes, I think of double standards in our society. And we're going to talk about the difference between females and males in our society. And this is a very broad generalization, but maybe this will help you understand. So females are our X's in these charts, are our inputs. The Y's are our males. Double standard in our society is that females, if they're seen with more than one guy, they're not looked too highly upon. But if males are seen with 2 other girls, they are thought to have being super cool. So if we take a look at these here in that respect. So on the first one, we got different couples. We got 2 with an 8. We got a 4 with a 3, 7 with a 9, 9 and 12. Nobody's cheating. Nobody's double crossing anybody there. So it's a function. The second one, we can see the ones that I have circled. The 6, that females with a 9, and then that females with a 12. So this one, we got a cheater here. Number 6 is a cheater, so we'd say that that's not a function. Okay, if we take a look at this one, we can see that this male, this 3, has 2 different inputs that it's paired with. But in our society, that is okay, so we still consider that a function. And then the last one, there is no one cheating no one. So we are okay. We've got ourselves a function. Okay, so a couple more examples here for you to try and work out. So if we talk about a linear function is something that just graphs to be a line. So is this one a linear function? Well, all you'd have to do is graph it to see. So I got a 0, 1, a 2, a 3. And if I went by 2's here and I graphed it, I'd have a 0 and an 8, a 1 and a 10, a 2 and a 12, and a 3 and a 14. We can see that this is a line. So is it a linear? Yes, it is. Describe it in words, an equation, and a graph. Well, I've got my graph already. In words, it would be something like this. When x equals 0, y equals 8 for every increase of 1 in x, y increases by 2. That's the horrible increases. My handwriting is not so good on this thing. There. Okay. And then the equation. Equation, again, we have to think of a start, and that's at 0. And then we have to go increase or decrease by. So our start with here is an 8, and it increases by a 2. So our equation would be y equals 8 plus 2x. Okay. So if we wanted to explain this one, we can go 0, 2. We can do a 1, 4. We can do a 3, 5. We can do a 1, 8. And it's asking, is it a linear function? And we would say no, it is not a linear function. And one of the reasons why, we could simply say it doesn't form a straight line. Okay, the next two, why don't you just try this one on your own and this one on your own. And if you have questions about them, bring those back to class tomorrow. Okay, and that is a wrap.